So our last topic in this section is about functions of 3 variables. So throughout this whole thing, we've only focused on functions of 2 variables, but you can do all of the same stuff with functions of 3 variables. So then we would say the directional derivative of f in the direction of a unit vector u, which now is going to have 3 components, ai plus bj plus ck, is given by xyz. It'll be a times your partial derivative with respect to x plus b times your partial derivative with respect to y plus c times your partial derivative with respect to z. But it's still given as the dot product of your gradient. I guess I should define gradient first. The gradient of f is fx I, then I can take the partial derivative with respect to y, and then I can take the partial derivative with respect to z, and I'll say that all the same properties hold here. I'm not going to run through them all, but in particular, one thing you want to mention is that your directional derivative, it's the dot product of the gradient with the vector u. Alright, so let's look at a problem involving a function of 3 variables. So let's look at an example. Find the gradient of f of x, y, z for the function f x, y, z will be x squared plus y squared minus 4z, and find the direction of maximum increase at the point 2, -1, 1. So the first thing we're asked to do is find the gradient, so let's do that. Remember, our gradient is given by the partial derivative with respect to x, I, plus our partial derivative with respect to y, j, plus our partial derivative with respect to z, k. So then take the derivative with respect to x, you'll get 2xi. The derivative with respect to y is 2yj. With respect to z is -4k. So here's my gradient. So I've answered the first part of this question. The second part says find the direction of maximum increase. So remember that the direction of maximum increase at a point, in this case 2, -1, 1, is given by your gradient. You just need to plug in your point, 2, -1, 1, into your gradient. So you'll get 4i minus 2j minus 4k. And that is going to be your direction of maximum increase at that point.